I hope you have a great morning or great afternoon, some of you, and I hope you have way more better weather than I do because it's stormy and rainy like hell here. So great to see so many of you. It's always a pleasure to see so many people attending. And as I announced last week, we'll be doing a kind of follow-up on the webinar of last week, and we'll focus mostly on Ingress controllers and how it complements clustering, IPs, node port load balancing, and so on and so forth. There's a very small recap. If you need more information about that, just check out the webinar of 2 weeks ago. It's explained and demoed in all detail, but I need these fundamentals for what we're going to cover today. There will be a larger demo today, so let's hope the demo got with us. I also want to introduce my colleague, Jane. She is also a panelist. She's based in the UK. She's taking responsibility of everything around sales and account management. I'm a techie, so I'm Philip. If you want to check us out, feel free to go to LinkedIn, of course, and ask any questions that you might like. So this is all in the context of free learning around Project Calico. As you probably already know, Project Calico is a community-driven project, which is actually building an open source networking and security solution for containers, but also for virtual machines and host-based workloads. So we typically focus on containers and Kubernetes, but you can use it in a wider or broader approach to interconnect both worlds. Please use our Slack channels. I learned from my colleague that people were using Slack last week, 2 weeks ago, to discuss topics. Well, there is a free training Slack channel. Feel free to join it. We might respond to questions afterwards on it. So please head out to Slack if you're into it and contribute to the live discussions. Any suggestions for laser trainings or free trainings, please drop them over there and we'll take a look at it when we have to come up with new titles. So please do so. So today we're going to talk about Kubernetes Ingress, not Ingress policies, as you might know is also a concept in Calico. Kubernetes Ingress today will focus on the, how would I call it, reverse proxy / load balancer approach to make sure that we can actually bridge users are sitting outside of Kubernetes to the right pods and applications inside of our Kubernetes cluster. That being said, as you know, applications are deployed inside of Kubernetes by pods. Typically, they're used or deployed through a deployment resource. And a deployment resource typically lists what containers to use, of course, but also how many of these containers or pods that need to be available at any time, so the replica set. So once the deployment has been run, there will be 3 Nginx pods running. Calico will make sure they get an IP address, and very importantly, to be able to reach these pods, which have dynamic IP addresses assigned by the IPAM of Calico, you need to make sure that you have a generic way to access them. One of them is through means of a Kubernetes service. A Kubernetes service is a Kubernetes object, which basically abstracts the pods. The cluster IP resource here is represented by an IP address, which is typically a virtual non-routable IP address, but it's resolved by DNS. So pods that want to read the service can basically resolve to the DNS name or look it up in the etcd database and actually connect to one or the other pods. This load balancing has nothing to do with Ingress. This is implemented with address translation and IP tables. So if you push it any further, this is inside of the cluster. If we want to make an application available outside of the cluster, there are a few options. One option is node port. Through means of node ports, we are actually going to make sure that that cluster IP is also reachable on the network interfaces of the Kubernetes hosts. Quite often this is done on a very high port number, like 30,000 something. But this actually means once you apply this service definition of type node port, any Kubernetes node will have port 30,970 open in this case. And that's where you can actually reach the service. Now, this is cool. This is an easy way to expose a service. But of course, nobody knows about these ports because they're quite often randomly assigned, although you can fix them, but still they are in a higher port range. So it's pretty difficult to get them basically address translated and make available, for example, from the internet. So if we push it one step further, we can actually use, as I explained 2 weeks ago, the load balancer concept. The moment you define a Kubernetes service of type load balancer, your Kubernetes cluster will typically connect to the cloud provider or through a load balancer controller to an external load balancer to basically configure and set up a load balancer automatically. For example, I use DigitalOcean, but you can do it with F5, you can do it in AWS and so on and so forth. The moment you actually do this, a load balancer has spin up inside of your cloud infrastructure, and he will actually complete the path. So your load balancer might expose port 80 and 443, which is typically something you can reach through any type of firewall or proxy. Once you hit a load balancer, well, your load balancer knows how to reach the nodes of your Kubernetes cluster. That's why Kubernetes has to be able to talk to the load balancer. So there needs to be an integration. And your load balancer will send it to one or the other higher port number, in this case 3970, to one or the other nodes. Now, the downside of this implementation is there is no layer 7 awareness. That means that if I would spin up in another namespace, another application, and I would expose it to the load balancer, what would probably happen is that a new load balancer is being brought up inside of the cloud on another IP address and to reuse port 80 or 443. Now, it's an easy way. It's a fully automatic way. The problem is that it will use at any time public IP addresses, and you might be billed for more and more and more load balancers. And in some clouds, these load balancers are more expensive than actually the nodes themselves. So be careful with it because it happens automatically, and you might end up with quite some load balancers. Although this is a very cool way, it's a layer 4 way, so it means there is very or no layer 7 awareness. If you can connect to the load balancer of the IP, well, you will be redirected to one of the services via the node port to one or the other pod. So that being said, that's what we've been using quite often. Please note that the load balancer is not an integral part of Kubernetes. It's something you have to basically connect to it and make sure it's integrated. Now, if we want to push this a little bit further, we're actually in the domain of ingress controllers. This was basically what I was saying. If you spin up multiple load balancers, well, they might up ending different load balancers, different IP addresses. You need to update DNS and so on and so forth. So something to keep in mind. So how can we basically make this a lot smoother, cheaper, and probably way more flexible. Well, this is through Kubernetes Ingress. Now, an Ingress controller is typically a kind of load balancer, a reverse proxy, or an edge router. You find a lot of different names, naming conventions on the internet. For example, we can talk about Nginx controller, which is typically a reverse proxy with some load balancing capabilities, but it can also be an F5 load balancer. We can talk about Traffic, we can talk about Kong, Envoy, and so on and so forth. There's a very, very long list of solutions available that can act as a kind of Ingress controller. Typically, Ingress in Kubernetes, and I stress only Ingress because there's a lot of exceptions, typically expose HTTP and HTTPS. When we talk about exposing HTTP and HTTPS, we might think layer 7 reachability. Layer 7, we are aware of what is happening inside of the HTTP or HTTP connections. So we can do some more advanced things. We can, for example, route traffic based on the host name, name-based virtual hosting. We can do stuff like TLS and SSL offloading. We can do more effective load balancing, because if you remember, when we use cluster IPs or something similar, it's basically a random distribution on layer 4. There's nothing intelligent about it. So with a pure HTTP load balancing algorithm and stickiness, in some cases, we might do some more effective load balancing. And last but not least, through Ingress, we can actually put a name to what URLs are actually reachable. And I find it from a security point of view a very good thing that you cannot reach applications just by simply typing an IP address, but you actually must to know the host name of your application. So Kubernetes Ingress, although the API is something which is standardized by Kubernetes, the Ingress controller itself is not something that is inside of Kubernetes. An Ingress controller is something you have to install additionally on top, just as you would have to install or integrate a load balancer in Kubernetes. Now, there is a very long list of Kubernetes Ingress controllers, some simple, some very more advanced. The most known ones are probably Traffic, Nginx, Kong is pretty known. Ingress from Istio, yeah. So there is also a series of Ingress controllers which are basically based on Envoy, like Istio, Glue, I think Contour, if I'm not mistaken. And then you have a bunch of commercial ones like F5, AVI Networks, which is VMware, and so on and so forth. So if you want to see the list or concepts, I showed the link downwards on this slide. So feel free to check it out. To be honest, whatever you use in this context, pure from an Ingress point of view, it's actually the same. If you want more advanced features, we'll talk about that in a second. Then it's, of course, worth looking into these products to see whatever functionality you need and how you can actually address it. So installing Ingress controller is pretty easy. As usual, it's just copy-paste a link, but it's always interesting to know what it is doing. So quite often when you install an Ingress controller, is installed in a specific namespace. This is often in default. I don't think this is a very good practice, but quite often it's installed in the namespace default. Since it is very often Envoy or Nginx or something similar, it means that on one side, an Ingress controller is actually talking to the Kubernetes APIs to actually figure out all the pods and stuff like that, and services. But on the other hand, your Ingress controller also need to be able to actually listen on ports like a node port, or even port 443 or port 80. That means that there are basically two sides quite often on an Ingress controller. One is the integration with Kubernetes. The other part is actually on which ports does my Ingress controller actually listen. For example, Traffic can be installed so that it actually listens on port 80 and 443. Nginx typically will listen on higher port numbers and requires a load balancer, although you can change that. So very often there is a configuration map, a config map in Kubernetes that actually holds the configuration of your Ingress controllers, so that if you start scaling your Ingress controllers, that they all receive exactly the same configuration. Ingress controllers do need to talk to the Kubernetes API, so they have secrets, they have service accounts, and so on and so forth. They need to store certificates because Ingress controllers can do TLS offloading. So secrets, service accounts, they're all joining the party. So if you deep dive into Ingress controllers, there's quite a lot of stuff that goes along with it. So if you use one, check it out. Where is it sitting? Looking into the config map is always very revealing to see how it is configured. I have a few examples so we can look at them. So the moment we actually have a deployment and we have our Ingress deployed, so as I mentioned, the Ingress controller is specifically installed in a specific namespace. Like anything is installed in Kubernetes in a specific namespace. The Ingress configuration, so once you're going to expose a service, like you create a service or a load balancer, that's done in the namespace of the application, okay? We'll see that in detail. So once the Ingress controller is configured, the Ingress controller is typically exposed through node ports, although it can be different depending on what type of Ingress controller you use. And then it's very often preceded by a load balancer. Now you would say, why would I do this? Well, when you do Ingress, you only have one node port, which your load balancer need to be aware of. So we're not going to recreate load balancers every time we want to add an application. We're going to leave this as it has been designed here, but we're going to add Ingress. Every time we're going to add an Ingress resource, well, it will be configured on the Ingress, but let's say on the node port or on the load balancer part, we're off the hook. We don't have anything to configure anymore. And since our Ingress is layer 7 aware, we can mix and match stuff based on host names, paths, and so on and so forth. So we typically call it a load balancer, but some people refer to it as an edge router or an application router or something similar. So the moment you actually define the Kubernetes Ingress resource, as you can see, you have to specify, first of all, in which namespace it needs to be deployed, on which host name it listens. So host here refers to essentially the host name. It will be available on the internet in this case. So this is the host name, what you type in URL. And it's basically referring to a service name, which is the service that you created of cluster IP. Now, I made a mistake myself when I was exploring this a few months back. It's not as simple as thinking that the ingress is just sending it to the cluster IP, and the cluster IP is actually sending it to the pod, which would be the purpose of load balancing. Ingress controllers can do actually load balancers. So that means that they will use the service definition by which they can find the service endpoints. And once you know the endpoints, once you know that pod 1, pod 2, pod 3 has this specific IP address, well, the ingress is configured to actually connect directly to the pods, can do, if you want, additional health checks, and do true load balancing, and use, if necessary, stickiness, cookie persistence, authentication, and that kind of services. Now, what I said, cookie persistence, authentication, is not pure ingress, but we'll talk about that later. Okay, so it can act as a real load balancer, and based on the rules, you can actually specify on which host name, or it could be which path, you can actually send it to what backend. See, one question is the ingress controller typically a single pod? That's a tricky question. It can be one, for sure. In Kubernetes, you know that if a pod dies, another one will pop up. So there is a kind of resilience, but it will take a few seconds, of course. So I would at least suggest to have, for example, 2 or even 3 ingress controllers, so that you make sure that always one is available. Make sure there are health checks on it, because if we don't know that an ingress controller died, we're in the same scenario. Now, there is one thing I noticed is it will work with 2 or 3, but there are solutions that have automatic integration with Let's Encrypt. And when you have an automatic integration with Let's Encrypt, having multiple pods as ingress controllers will not work accordingly. For sure, not with the open source versions. So that's one thing I saw as a downside to having multiple ingress controllers. But I would say in general, for example, if you're using Nginx and you have a great way to manage your certificates, for example, with Cert Manager, having multiple replicas is not an issue as far as I know. Okay, so this is the entire chain. The cool thing is that you lower the cost of your load balancer. You're not burdened with all these higher port numbers and all the new, let's say, routing for incoming HTTP and HTTPS connections can be handled by Ingress by a YAML syntax, which basically specifies a host or a path or a combination, pointing it towards some other service from which we can actually deduce the endpoints. So there are a few types of ingress. So that can be a single service ingress. The one I just showed basically means you come in and you go to a specific service backed up by a few pods. You can actually do it based on virtual host names. That's actually what I just showed. Yeah. So based on, for example, app 1, you can send it to service 1. If app 2 dot something comes in, it goes to. You can also do it, for example, in a combination, like in this one, everything which is sent to the host name foo.bar.com. Yeah. If it has a path/foo, we go to service 1. If we have a path2/bar, we go to service 2. So think about this. This is actually a reverse proxy/load balancer that based on URIs or based on paths, can send it to one or the other service. So this is really what we would call layer 7 routing. That's why quite often it's called edge routers or router functions or something like this in Kubernetes lingo. And last but not least, there's also support for TLS. So an Ingress controller has the ability to terminate TLS or SSL so that all connections originating from a user up to the Ingress controller can be encrypted. We use server name indication for this. So you can use the similar concepts. Server name indication is basically the ability, to have an Ingress controller listen to the SNI header inside of a TLS handshake. So this mechanism is not only bound to HTTP, but also to HTTPS if you want to do that, and which is, of course, recommended. Take a look at it. If you go to the Kubernetes website, you can find all the information. Now, one thing I want to point out, and which is on this slide, is Kubernetes Ingress is cool. It fits quite some use cases, but in all honesty, it lacks a few functionalities, also what you might expect from reverse proxies or others. Quite often, if you use, for example, Nginx or Traffic or something else, well, you can do that through annotations. Through means of adding an annotation, you can actually signal, in this case, to Nginx to use one or the other functionality. But whatever you see in the annotation list, you can be assured that this will only work for that specific type of Ingress controller and not for the other. Traffic solved this a little bit differently. I hope I can show this in the demo. But this is in general how it is used. And you see this quite often, for sure, that Ingress resources are typically referring to Nginx or something else. Now, as you know, and I already told you, Ingress can do TLS offloading. When you want to do TLS offloading, that means that you have to have certificates. So how do you solve that? First of all, you need somehow to generate certificates. That's a fact. And second of all, you also have to store the certificates. So let's assume we have some certificates. We got them in one or the other way. We can do it manually. I'll show you how to do it. Or you can use an integration with Let's Encrypt, or you can use, if you want to use Let's Encrypt, you can use Cert Manager and it will do it automatically for you. But it's quite a long installation process, but it works fine. Or you do it manually. But at the end, you'll end up with a certificate and a key, and you need to store the certificate and the key somewhere. Well, these certificates and keys are stored in a secret. So the Kubernetes Ingress controller can talk to the Kubernetes API and actually retrieve the TLS certificate and the key. So it's up to you or one or the other controller to put it actually in the Kubernetes data store. One thing I spent quite a lot of time on researching, they have to be named tls.cert and tls.key. So don't go and do like demo 1, demo 2, it doesn't work. They have to be named tls.cert and tls.key for the Ingress to pick them up. So back to our Kubernetes Ingress definition. So if you want to do the TLS offloading, once we have a certificate, it's pretty simple. You basically say the name as we did before, and we refer to the secret that holds the certificate and the key. doing this, as I mentioned, requires the understanding of server name indication. As you know, an Ingress controller does have to present the right certificate. If you want to connect to app1. In this case, TLS app1.dockersig.me, well, this is typically in the host header, but since this is not visible when it is encrypted, we need to find another way. Well, your browsers do point the host name or put the host name inside a TLS header field when you set up a TLS connection, which is called the server name or indication, which is what is referred to as SNI. So Ingress does know this, and the Ingress controller will, based on the server name that is mentioned, present the right certificate to the browser so that you don't get any error messages. And once that is done, it will decode TLS connection, and then it will actually apply the rules that are actually specified below. So in this case, when the host name is TLS app1.dockersig, well, we'll basically send it to the Nginx cluster IP. So it's a bit complicated first time. It's a little bit challenging to do that, but once you get the hang of it, it's pretty straightforward. But it's a cool way, and if you check out my LinkedIn profile, you see I'm a long-time fan of SSL and TLS, and I would encourage at least up to the Ingress controller to have encryption. Now, Ingress, although I like the concept very much, there are some pros and cons, of course. The cool thing is that an Ingress is a Kubernetes API object. That means that no matter what Ingress controller you're using, the resource definitions can be applied anywhere. So if you want to rip out Nginx to replace it by, I don't know, Traffic, for example, you can do that, or with F5 at a given point. You can perfectly do that. Now, the downside is that from a pure load balancing concept, Ingress is, I do have to say, a little bit limited. For example, in some specific high secure environments, you basically want to do layer 7 switching, but inside of your Kubernetes cluster, you still need to have TLS support, or the application that is running in Kubernetes is only being fronted by TLS. So with Ingress, as far as I know, pure Ingress, it's not possible to basically terminate the TLS connection and re-encrypt to the backend. Yeah? So it always have to be in HTTP. There is no support for authentication in pure Ingress. There's no, and that's a little bit worse, is no support for TCP or UDP. It's only for HTTP and HTTPS. So, and there are probably a few other ones that can mess up our thinking when we want to apply it. But the good news is that almost every Ingress controller that I've looked at has the ability to use these advanced or more advanced features. Some of them do this through annotations, like you've seen for the Nginx. Other ones, they just created a specific CRD, like, for example, Traffic. Once you want to install Traffic, you can install a custom resource definition, and it's not called Ingress, but Ingress Router or Ingress Route, if I'm not mistaken. Well, and you can do something similar. So there are a few ways around this. I got a very cool link. It's down in this slide, which is basically a comparison of a lot of different Ingress controllers with the pros and cons. Something was shared on Learn Kubernetes. Feel free to check it out. It's not my link. I didn't participate in any kind of context to this link. But if you're interested, feel free to check it out. I found it very interesting, and it has a long list of features that were analyzed. Now, at Calico, we are concerned about all the security. Yes, I will share the presentation, and I can share the links straight, no worries. So about Calico and Ingress, as you probably already understood, Ingress controllers are not part of Calico. Although I have to say that Calico Enterprise will soon have layer 7 routing included in some form, but that's at some time from now, but we're working on it. But the core concept here where Calico fits in is that Ingress is basically a layer 7 hub, and we need, of course, the security not to be forgotten. So once we're talking about Ingress, we need to take care of our security policies. And one part of the security policies is that our Ingress controllers will start talking to our pods, yeah, and not the node IP address. But that's something you can fairly easily do with Calico. It's just your Ingress controller that actually needs to talk to the pods. So that's something very easy to do with labels. Of course, we need to look at who and what can connect to our Ingress. One side note is the way I installed the Nginx controller early on. It's running as a pod, so you can use simple, normal Calico network policies to do that. But you will find on the internet also solutions that actually turn up the Ingress controller so that they actually listen immediately on the host IP addresses or the network interfaces of the host. Well, you can also protect it with Calico, but then you have to look at what is called host interfaces. But Calico can perfectly do this. Now, in a normal scenario where it is running as a pod, let's say, like any pod is running, the last part where we need to take care of the security is, of course, on our load balancing. Most cloud load balancers have the ability to apply access lists and so on and so forth. Yeah? But this is outside of control of Calico quite often. This is in your cloud or your external firewalls. So everything I'm going to show right now is in GitHub. So I'll do the demo straight away. I'm going just to finish off these slides and then I will jump into the demo. There are upcoming events, even tonight. There's someone, so if you want to join, you already know, go to Tagera.io events and sign up, please. And we're happy to welcome you. I'm not sure if the next one in EMEA is on this list already, but the next one in EMEA, I think, is troubleshooting microservices, which is a little bit even more advanced than this. So I think it's in 2 weeks from now, where we'll be troubleshooting most of the stuff we've seen. Already a lot of people did it, but there is a free certified Calico training. It's a very hot training. We see really very, very high numbers. You can actually go sign up and do the certification, and then you get a certificate that you passed the Calico training. It's very cool. It's very hot topic. So prove your knowledge. It's free, so why not give it a try? There's also a very nice ebook that handles most of the networking and services, so it can serve as a very good summary of what we've seen and discussed and add context in the last couple of seminars. So check it out, download it. It's a very good read. I wish I had it 1 year ago. then I would spend me a lot of research on the internet. Calico Enterprise, as you know, has more stuff to it. It's not the main topic of today, but when we talk about security, when we talk about Ingress, when we talk about layer 7 and so on and so forth, DNS policies, for example, IDS, performance, are all very interesting things, not even to forget, for example, intrusion prevention. I always forget to correct this, so thank you for this. And it's solved. So take a look at Calico Enterprise. If you want to test it out, go to the website, you can sign up, you have a free trial, or you can have it actually in a sandbox. Check it out. So always a good thing to do. So let me share. So let me go to find the right web pages. Okay, so we should be here. So this one is a Tigera workshop link, which is in the presentation. So I'll copy paste it here. So it's in the chat. So it's basically a simple script I use to set it up. So let's give this a try. And here I have, let me see. Yeah, so let me clear this up. So what I did for the demo is pretty, getting messy with more screens. Okay, sorry for this. So this is basically just a few things to do if you want to set it up. Well, it's pretty easy. So let's me first check if I am actually connected to the right cluster. So cluster 1, and let me check whether I have namespaces. Okay, there is already an Ingress Nginx one. That was to save time. So everything is inside of this repository, so you can actually copy paste it to your machine. I already did this, so I can go into this. Okay, and then I have two applications, nothing very fancy, just Nginx. And I'm going to deploy this Nginx deployment, and I'm going to basically create a service. So if everything worked fine, I should see get pods inside of app 1. I have 3 Nginxes running, yeah, and I should also have a service of type cluster IP, nothing fancy, something we've done already a few times. So we can create exactly the same thing for a namespace called app2, same deployments, same cluster IP. Everything, as you know, is namespaced. So basically, if I would check if there is a service for app2, there would be one. And if I have a pod, they should be deployed. Also, nothing really fancy. So if you want to see all the IP addresses, which is basically interesting to see once you want to know. So as you can see, there are 3 IP addresses of these in F1, which are totally different IP addresses than the ones you actually see in, sorry, that was the wrong copy paste. Okay, so there are other IP addresses than the ones you would actually see in F2. Now, you can actually generate traffic to it. So I will do it for one or the other. So this is something I use. It generates quite a lot of traffic. So I'm going to run actually stress test inside of it. And if everything goes well, well, it can actually generate hundreds of connections. So it works well. You can actually see that I have connectivity, it's available, I get 175 hits and so on and so forth. So that just, bottom line, is to create 2 applications in 2 different namespaces and so on and so forth with a simple cluster IP address. Now, to deploy an Nginx Ingress controller, it's pretty easy. This is something I got from essentially the websites where you can actually see how to install the Ingress controller. I'm not going to do that. I already did that. Otherwise, my load balancer has to be updated and it takes minutes. But believe me, I did this just before the demo. So it's pretty easy to do that. So once you do that, you can actually see that this would have created a namespace called Ingress Nginx. Yeah. And if we would take a look at it, we can actually see that at this moment, there are actually, there's only one Nginx controller running. Yeah. But as I mentioned, you can actually scale this to 2, 3 or more replicas. And most importantly, this Ingress controller is just a pod like any other pod. Yeah? There is also a service being created automatically that basically says that that Ingress controller has a node port. You see 3254 for 80 and for 443, some other port. And it is made available through a load balancer on this external IP. So if you hit that external IP right now, you're going to actually hit my load balancer. Now, it's not exactly the same. The script here is basically made so that you can do it on a notebook or any Linux machine. But at the end of the day, it will work. So if we would basically do a curl to here, you can actually see that it says for not found for Nginx. Yeah, that's because we're hitting the Nginx Ingress controller, but since it has no default page configured except answering for not found, yeah, nothing is going to show up, of course. So let's try to make our Ingress work. So here is an Ingress definition. So we're going to actually say that we're going to expose this application, but I changed it to Docker hack.me. We're going to make sure that this application is being made available on the internet on this host. So if you want to try it out yourself, you can, but you have to change the host name or use the trick I showed here below. So that will work also if you want to try it on your own machine. So if I'm going to apply this Ingress in this case, it's created. So if we take a look and we say get Ingress resources for the namespace app1, if everything works out, we'll see that it created an app1. Yeah. Currently in app2 namespace, nothing is defined. So let's see if everything I'm saying is all right. So if I would go to app1.hack.me without typing mistakes, you see I'm actually going to my Nginx backend. If I would type app2, I hopefully still get the not found. So if I would apply right now my Ingress for my app2, so as you can see, I'm going to apply it a different one with a host name app2 in namespace app2. It's created, and if we check, we're going to see that it is hopefully there. And if I switch back to my browser right now and I would refresh this page, yeah, you see app2 is also working. Of course, it's a lot of work to just see welcome to Nginx, but just to prove the point, it's pretty easy to do that. And if you want to host like 50 apps behind that Nginx controller, you can actually do that. Yeah. Now, of course, I want to have this secured. As I mentioned, you can go through Cert Manager or something else, or let's encrypt integrations and so on and so forth. But I always prefer to do it the hard way once, so that we can actually know how it actually works. So we're going to create a certificate, and to create a certificate, I have this one liner here that basically says, and I need to change this to otherwise my domain name is not correct. So if you go to OpenSSL, blah, 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 it will actually create a certificate. Yeah. These certificates are stored here, so you can see the TLS sort and the TLS key. As I mentioned, we need to put these certificates into the Kubernetes data store, so we need to create a secret for that, and we can do that as this. So right now, Kubernetes knows, or your Ingress controller knows where to get that secret. Now, we're going to update, of course, our Ingress controller, so it will basically do TLS offloading. So I already prepared this, so we're just going to apply this YAML file. Voila. And let's check what has been done. You see, we created it. So if I'm lucky and I would switch to this URL in HTTPS, I will get a certificate warning because it's a self-signed certificate. Yeah. And yeah, this is Chrome not liking it, but it is, let me use Firefox a second. Yeah, you see, it is working, but it's saying that the connection is not secured because it will be a self-signed certificate. Yeah, so that's the idea. The idea is, of course, that you have certificates which are, of course, signed. Yeah. Now, to give you in a few minutes some I'll share this link. This has nothing to do with Calico. I was trying for myself to see whether I could have it running on Traffic, so I'm going to share the link. But as I said, this is something in my repo, something I tried for myself once, but I can share it here. It's fairly easy to set up Traffic if it is in your own cluster. Now, it's all prepared here, so we can basically do this. Just to give you a counter example, so Traffic will use a custom resource definition so that you can actually use way more advanced functionality. It's pretty easy to set up. I also had to copy paste this. So this is just installing the CRD. This is making sure Traffic can use the Kubernetes API, of course. This is a way to make sure you can store certificates in Traffic. That's an important point because otherwise your Let's Encrypt will not work. And then you can actually deploy Traffic. Now, if you deploy Traffic, take a look at the file or the deployment file yourself. You can see that you can actually specify a lot of things when you boot up Traffic, like the addresses on which it listens and so on and so forth, how it can connect to Let's Encrypt and so on and so forth. So this configuration basically should work, or this example should work with Let's Encrypt. So that's why I created it. Okay, so once this is done, we need to expose, of course, our Traffic service to the internet. Now, this will take a while, and be careful, it actually creates a web UI access as well as where the web traffic will be held against. Now, if you look at it, get SVC, you have to wait a few seconds because it will actually create a load balancer, and that takes a few minutes. Yeah. The rest of this tutorial basically explains you how to make the dashboard of Traffic secured, yeah, so that you can log in and so on and so forth. So it's a more advanced demo, and we're running out of time. But if you just follow through it, you can actually start using it. And to close this, what you can do and see here is I set it up to point to this. It's authenticated, but I need to go in a new incognito window. So if you go to DB, you can actually see that it asks for authentication. The password is Traffic in this demo. And then you can actually see all the services and routers and so on and so forth. The cool thing is that it has a way more broader syntax, it's visualized, and it has TLS enabled through Let's Encrypt. So if I would connect to, for example, this link, you actually see that my connection is secured, and that is actually secured by Let's Encrypt. Yeah, and I didn't really have to do anything for it. Yeah, so if you just use a configuration and provide it for Let's Encrypt, and Let's Encrypt is able to connect to the domain name, Well, you can fairly easily get Let's Encrypt working. If you want to do it, go through the tutorial. It worked for me, and I replicated in this demo, just so it's pretty easy to do. And you will see that you also have way other options. Yeah, you can do Ingress like we did before, but you can also use what is called Ingress route, which is a way more advanced way to do the control. You have support for TCP, UDP, and so on and so forth. Check out Google, you will find it everywhere. I thank you. I hope it was interesting. I don't see any, open questions. Unless you have one, shoot now. And otherwise, I'll see you on the Slack channel. If you have questions, remarks, you can reach us. So please do so. And hopefully I see you in 2 weeks. And if not, feel free to join the sessions in the US. Thank you. Speak to you later. Cheers. Bye.